So on Friday is the exam review session for the final, probably. For number 4, they tell us it's a periodic with a period of 6. First is state whether it's even, odd, or neither. What did you guys say?
I didn't try the exam before I came, but over the origin, so it's odd.
It is odd because f of negative x is equal to a negative 4, which is apparently equal to negative f of x. Let's see. The way I like to do it is graph it, but essentially for it to be odd, when you have a negative x in the f of x, it comes out negative on the outside, right? That's the definition. So if we have essentially if we have a positive, if we have an x value, say like 1 or 2, and we make it, we take a function of it, we take a negative of it, we get negative. Let me say that again.
It's f of x equals negative f of negative. That's good. That's good.
Because the way I do this is by graphing, but I think they want you to write that out.
You want to do f of x equals negative f of negative.
Yeah.
So you see it like, so you make it a negative. Yeah. There's no 4.
Essentially, you need to write down these 2 parts because that's the definition of an odd. Yeah.
And you graph it fully, you don't know whether it's odd or even.
I would graph it.
But it doesn't tell you that's odd.
Say that again.
It doesn't tell you whether it's odd, even, or neither. So if you graph it, all you have is 4 and negative 4 points, and you don't know whether to go like it's negative over y-axis or it. So how would you know?
Without graphing it?
Yeah.
It's the way I've always thought of it is by graphing it.
Can you just graph it?
Yeah, I'll graph it for you guys. They don't show it in the work, but if I did this problem, I probably would have graphed it. So from negative 3 to 0, it is a 4. From 0 to a 3, it's a negative 4. So you can clearly see that it's symmetric to the origin. So that's how I would have shown it. But this is like the official definition of an odd, and since this was only worth 1 point, okay? So I think if you had, essentially the 1 point was for saying it's an odd function. That's what I think. So don't worry about writing this out.
It's a state y.
But, oh, it says state y.
You do f. Okay. F.
Then essentially just write this,
That's
because that's the definition of an odd function. And then write that it's a negative because the negative is on the outside. If it's even, write the definition of an even. Are we good with that, guys? Not to be too confusing. I'm going to take it away. So the second part is find the Fourier series. So that's finding the 3 components. And since it is odd, what do we know?
a sub 0.
Is equal to 0, a sub naught is equal to 0. Do you guys understand that? B sub n, the formula for that is 2 over L from 0 to L, f of x, sine of n pi x over L dx. Okay, so our period is 6, what is our L? 3. So we need to do this part. Okay. So this is equal to 2 over 3, going from 0 to 3, of f of x being a negative 4 sine of n pi x over 3 dx. That's just filling everything in. So simplifying that, we use essentially the u substitution. So this is where I said it's good to have done this before, so that you can remember. So this is negative a third. So we have negative a third that's on the outside. Then we have essentially the inside of the sign flipped over, so it's 3 over n pi times negative cosine of n pi x over 3, going from 0 to 3. That's equal to 8 over n pi cosine of just n pi when we put in the 3 minus cosine of 0. Cosine of n pi alternates, which forms negative 1 to the end, minus cosine of 0, that's just 1. Any questions on this? That's equal to 8 over n pi times negative 1 to the n minus 1. They want us to put in the Fourier series formula form. So those are the things that you do need to memorize. The formula for a sub naught, a sub n, and b sub n, and then the whole entire equation of how to write it. So f of x is equal to the summation of k going from 1 to infinity of b sub k sine of k pi x over L. That's equal to, now we have 8 over n pi, so the outside is 8 over pi, summation of k equal to 1 going to infinity of negative 1 to the k minus 1 divided by the k, which was this n that we had on the outside previously, times sine of k pi x over 3. And you can stop right there. Or you can substitute 2k minus 1 for wherever there is a k. So that will be negative 16 over pi times summation of k equal to 1 going to infinity of sine of 2k minus 1 times pi x over 3. And then all of that divided by 2k minus 1. So that's if wherever there's a k, you make it a 2k minus 1. 2k minus 1, it simplifies down to this. And we need to do that when we have where it cannot equal a 0. And if you want to go that route of making one summation. But any questions on this problem? Good. You guys have this copy down? The next one, they tell you it's a Fourier cosine series. What is cosine, odd or even? Even. So what do we need to find? A sub naught and a sub n. They tell us f of x is equal to x between 0, x, and 5. So our a sub naught is equal to 2 over L, going from 0 to L, f of x dx. So what is our L value in this? It is 5. Okay. The 0 to 5 does not mean that the period is from 0 to 5. The period would be like negative 5 to 5. and our L value. So then period would be from -5 to 5, or that would be equal to 10. 10 over 2 is equal to L, which is 5. Okay? So this is equal to 2 over 5, going from 0 to 5, x dx. That's equal to 1/5 times x squared, because it would be x over 2. The 2's would cancel. Going from 0 to 5, that's equal to 1/5 times 25 minus 0. So that's equal to 5. Okay. A sub n is 2 over L, going from 0 to L, f of x cosine of n pi, x over L dx. Essentially, now we know, since it's f of x times cosine, it's going to be increasing by parts. So that's equal to 2/5, going from 0 to 5, x times cosine of n pi x over 5 dx. Our u value is x. Our dv is cosine. Our u value is x. Our dv is cosine of n pi x over 5. So then our du is dx. Our v is the integral of cosine of n pi x over 5, which would be u substitution. So that's 5 over n pi times sine of n pi x over 5. Do you guys all see how that works? So this is equal to, what do they do? So what do we use now? Ultraviolet voodoo? Yep. I don't know what they did here, but we're just gonna see, and then this should work out. Right, guys? Yeah, okay. So we have 2/5 always times u, which is our x value, times v, which is our 5 over n pi times sine of n pi x over 5. And then we plug in the values from 0 to 5. Right? That's uv minus v du. So it's the integral of v, which is 5 over n pi times sine of n pi x over 5 times du, which is dx, going from 0 to 5. So for this part, we have a value for x of a 5 and a 0. So we have 2/5 times, essentially. So this is 25, or in order. The 5s should cancel out, so we have 2 over n pi.
I mean, I would worry if
They-
the part goes to 0.
Yeah, but, oh, sorry. We plug in the 5, so we get 25 over n pi times sine of, if there's a 5 here, n pi, and yes, that just goes to 0, minus If we plug in a 0 here, the whole thing is a 0. So this entire part goes to 0. Minus. With this is a constant, so that can be on the outside. But we do substitution, which is multiplying by essentially the reciprocal of that. So we get 5 over n pi times 5 over n pi times the cosine of n pi x over 5, going from 0 to 5. And this whole thing is multiplied by 2/5 from the outside. So this here is 25 over n squared pi squared. Do you guys have this copy? Or do you guys have any questions on it? It's good to go through a integration by parts on this, so that once you've done it, you can sort of remember the process while on the test. Because this test will probably be long. Okay. So then that was equal to 2/5 times 25 over n squared pi squared. And then if we plug in a 5, we get cosine of n pi minus cosine of 0. Okay. Well, we already know that cosine of n pi is -1 to the n. Cosine of 0 is just 1. So this is equal to 10 over n squared pi squared times -1 to the n minus 1. Okay. The formula for an even function f of x, and you need to know this, is a sub 0 over 2 plus the summation k equal to 1 going to infinity of a sub n cosine of k pi x over L. Where's the sign-in sheet? Who hasn't signed? So you can pass it there and then back. Thanks. So with f of x, we found a sub naught to be 5. So we have 5 over 2 plus 10 over pi squared is our constant times the summation of k equal to 1 going to infinity of -1 to the k minus 1 divided by k squared times cosine of k pi x over 5. Now there's something that I need to write. This is not a final answer. What am I missing? Yeah, they told us it's 0 to 5. So then here we are required to write 0 less than x less than 5. And apparently that's worth 3 points in order to mention that we are limited by these boundaries for the x value.
They don't make you do 2k minus 1 and all like that.
You could put your answer as that too, so I was going there. Or we can do 5 halves minus, if you substitute 2k minus 2 for everything, we have 20 over pi squared times the summation of k equal to 1 going to infinity of 1 over 2k minus 1 quantity squared times cosine of 2k minus 1 pi x divided by 5. And you again need to write this. So any questions on this problem? No? Okay. For number 6, they tell us it's an even expansion, and they give us that f of x is equal to 1 minus x between 0 and 1, and x minus 1 between 1 and 2. So you can graph it. First thing you should always graph is what you are given. Okay. So between 0 and 1, it's 1 minus x. So that's the curve. Between 1 and 2, it's x minus 1. So it's like that, right? And then you're told that it's an even curve. So then it's symmetric with respect to what? The y-axis. So you just draw the mirror image. And then you're asked to write those formulas. So between -2 and 1, what is the formula for it? Negative x minus 1. So if it's negative x, going to minus 1. And between -1 and 0, what is the formula? X plus 1. Yep.
That was 6 points.
Apparently. Any questions on this? Now, if it was an odd function, we can look at that too. That'd be fun. Let's see how that would look. If it was an odd function, how would it look between -1 and 1?
It would be like you connect the -1 on the x to the -1 on the y.
Yeah, I think it'd be something like that. Right? Yeah. So this would be the odd way, and you could have easily had to do that, but in this one we want even. Okay. Oh, where is this? Any questions? No? Seven, we are told we have a period of 4 of f of x equal to 1 between 0 and 1, 0 between 1 and 3, and 1 between 3 and 4. And we have to sketch between -4 and 4. So first of all, what is our L value? They tell us that our period is 4. Our L is equal to 2. So first graphing just with that, it's 1 between 0 and 1. It's 0 between 1 and 3. And it is 1 between 3 and 4. Okay? So it's a periodic function. So it repeats the same on both sides, right? Just by looking at it though, that between 0 and 4, we only have it going one place value, going to 0 and 1, right? So when we draw the other side of it, if it is repeating itself, it should look like what we had here between, or it should be two values. So between 0 and -1, it's a 1. Between -1 and a 3, and a -3, it's a 0. And then -3 and -4, it's a 1 again. Did that make sense? Because that portion just repeats itself along the number line. This portion repeats itself. But we are told that it is a period of 4, okay? And our L value is a 2. What do I need to, what essentially is our function or period? You know how they like put a square around it in the graph? Which it'd be -2 to 2. So this is our actual function period. That has a period of 4 and an L value of 2. Do you guys all see that? From -2 to 2. So then when we find our A sub naught, we have 1/2. So I'm not writing the formula out, but it's essential. So it's
Did they do 0 to L or -L?
they did from one part to the next part, which is fine, but they don't show it very well on here. Essentially, it is 2 over L. Let me see. So what they did was, I'll show both ways. So A sub naught would be, so 1 over L would be 1 over 2, right? And we multiplied that throughout the whole thing. So first we go from -2 to 1, where our f of x is 0, and then we have d of x, okay? Plus -1 to 1, where f of x is 1, when we have d of x, plus from 1 to 2, where our f of x is 0, and then we have d of x, okay? So these two go to 0, and we have here essentially 1/2 x going from -1 to 1. So that's equal to 1/2 1 times 1 plus 1, which is equal to a 1. Okay? So they multiplied 1 over L to all the other parts. Or I'll just write it. Or we could have A sub naught equal to 2 over L, going from 0 to L f of x dx, right? There we could have just done, essentially you have to look at the problem. We have 2 over 2 going from 0 to, since we're multiplying it by 2, and essentially for this part, we're only looking at this part of the function, since we know the rest of it is 0, right? So then our L value essentially here is 1. Our function is 1 times dx. So using this specific formula, they sort of altered it because we know that it's 0 at these two locations. If we pretend our period was from -1 to 1, our L value would just be, what did they do? That shouldn't be a 2 here. Should that be a 2 there? Yeah, that's 2 there. It's going from 0 to 1. The function is 1 dx over L. I get L stays as 2, and then you solve it. I sort of might have said that confusingly, but we just look at the, since we know these two parts are 0, so we're going from -1 to 1. We multiply it by a 2 because we know it's going to be the same from 0 to 1. This is just a 1. And then our L value is a 2, so you solve that out and you get, no, I had it right. This should be a 1 here. No, it should be, oh, sorry, yeah. It should be a 2. Oh, it's a 2. So you solve that out and you get a 1 as an answer. Yes. I don't know why I was questioning it. Are you guys good with this, or did I just confuse you even more? This would be the easier way to do it. Just 1 over L and then each individual part. The other problem, normally we do 2 over L because it's symmetric. But any questions on this? So the next part is finding a sub k, or a sub n, whichever one. So for that, we have 1 over L, which is 1 over 2, going from -2 to 1, which is a 0, dx, plus -1 to 1, f of x is 1, times the cosine. Essentially, you know these parts are zeros, so they didn't write the cosine, but the formula is with f of x times cosine of n pi x over 2 dx, plus going from 1 to 2 of 0 times cosine of n pi x over 2 dx. So here I should actually have cosine of n pi x over 2 dx. Okay? But these two go to 0. So then in that little part, we have 1/2 from this section times the reciprocal, not the negative reciprocal, but just 2 over n pi times sine of n pi x over 2 going from -1 to 1. So then this is equal to 1 over n pi, because the 2's cancel out. When we put in a 1 in there, we have sine of n pi over 2 minus sine of negative n pi over 2 but since sine is a odd function, essentially, all of it is equal to plus sine of n pi over 2. So then that is equal to 2 over n pi sine of n pi over 2. Okay. And this is where, it's especially good to have done examples like this, because the n values we're putting from 1 to infinity, right? When we put them in here, we get 3 different values. If we plug in a 1 here, sine of pi over 2 is what? Yep, so this acts like a positive one. So then we have 2 over n pi whenever n is equal to a 1, a 5, a 9, dot, dot, dot. Okay. When we have a 2 in here, we have sine of pi. So that is what? 0. So it's 0 when n is equal to a 2, comma 4, comma 6. When we have a 3 in here, we have 3 halves pi. Sine of 3 pi over 2 is what? -1. So it's equal to a -2 over n pi when n is equal to a 3, comma 7, dot, dot, dot. Okay. So you have to realize that you can have more than one answer in these. Okay. You guys good to move on? Or they could. What's it? They also did this sort of thing where they did the integral of going from 0 to 1 of 2 over 2 the integral, so 2 over 2 going from 0 to 1 of 1 times cosine of n pi x over 2. Since it's symmetric between -1 and 1, you can just multiply the outside by 2, and you end up with the same answer. But I've always preferred this way, even though I have to write out a bit more, because I see each part being applied in the formula. And then I have 1 over L on the outside. Okay. What is our b sub k value? 0. Why is it 0? Say that again. Because it's even, right? Yep.
Is that all we have to do? Can we just write 0 as even?
Yep. You can do all of the math. And you can always do all of the math for all of them if you don't remember.
You can always quote you.
You'll just get zeros as for b sub k or a sub naught and a sub n. But so for this, we have b sub n equal to 0 since f of x is even. Do you want me to go through the math? Or it's just use substitution. It's not even an integration by parts. So, or you can just write b sub k is 0 because of that. So then now we have to write f of x. So we have a sub naught over 2, which, what was our a sub naught? 1. So we have 1/2 plus 2 over pi from down here times the summation of k equal to 1, comma 5, comma 9 going to infinity is 1 over k cosine of n pi k pi x over 2. So this is positive. Like we got a 2 over n pi positive minus 2 over pi with k going from 3 to 7 to 11 dot 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 going to infinity of 1 over k cosine of k pi x over 2. Okay. You can combine them all if you make k equal to 2k minus 1. But you don't need to, but I will put the answer here anyway. 1/2 plus 2 over pi going from k equal to 1 going to infinity of -1 to k minus 1. If you do all the math, divided by 2k minus 1, or cosine of 2k minus 1 pi x over 2. So this part here alternates it, keeping it, avoiding evens and stuff. Any questions on this? I would just stick with this answer. I wouldn't try to make these substitutions with 2k minus 1 because they accept both, right? So any questions on this problem? Okay. Are you guys good to move on? So the good thing about complex Fourier series is that they give you everything. So essentially in the end it becomes just plugging and chugging. Part A, let me write out f of x. F of x is equal to -2 going from -3 to x less than x less than 0, and it's 0 going from 0 to 3. So then they tell us the formula for C sub naught, that's 1 over 2L going from -L to L, f of x dx. Okay, so we can do 1 over 2. What is our L value in this? 3, because the period is 6. 2 over 3. Times the quantity going from -3 to 0 of -2 dx plus going from 0 to 3 of 0 dx. So this becomes -2 over 6, right? Which would be -1/2 or -1/3. -1/3 times the dx would give us an x going into the integral. So then that's plugging in 0 minus a -3 for the x values. So then that's a +3. So in the end it's a -1. Any questions on this? Can I erase this? This was the old problem. Okay, for B, they tell us n goes from plus minus 1 to plus minus 2 and on, so it doesn't equal 0. And they also tell us that e to the I theta is equal to cosine of theta plus I sine of theta. Do you guys know that one equation where e to the I pi is minus 1 is equal to 0? Yeah. It's just a random thing. Have you guys ever seen this?
Yeah.
I don't know what it's called, but it's one of the coolest things ever.
Yeah.
Because you have the constant e, you have I pi minus 1 equaling to 0.
I was flipping out that over out to.
Hey, there you go.
But we're gonna.
Why is that cool? I don't get it.
It includes one of the three biggest constants. Like it includes a pi and e and I
All at once.
minus 1 equals to 0. No. That was a side note. But going back to this, for c sub n, they tell us we have 1 over 2l going from negative l to l f of x of e to the negative I n pi x over l dx. So then we make the substitutions. We have 1 over 2 times 3 for l going from negative 3 to 0 times f of x is a negative 2 e to the negative I n pi x divided by 3 dx plus, and then this is just going to be 0. So then we have a negative 2 divided by 2 times 3. And then if we do the integral of that, we have to write the upside down of what e is to the power of. We have negative 3 divided by I n pi times e to the negative I n pi x divided by 3. Essentially going from 3 to 0, negative 3 to 0. Okay. And we have an I in the denominator, so they like to multiply by I over I to get in the numerator. So then we end up with I over I squared n pi of e to the 0, or e to the 0 power minus e to the I n pi. Because when we put a negative 3 in there, it becomes a positive I n pi. This equals a negative 1. And e to the 0 is a 1. So now we make the substitution. We have negative I over n pi. And then we have 1 minus the quantity of cosine of n pi plus I sine of n pi. Do you guys see how that happened? So e to the I n pi, or e to the I theta, can't do that, equals cosine of theta plus I sine of theta. So we have e to the I, and theta is essentially n pi. So that's where we make the substitutions here. We know that cosine of n pi is negative 1 to the n. Sine of n pi is equal to 0. So this goes to negative I over n pi times 1 minus negative 1 to the n power and since we have a negative on the outside, we can rewrite this as I over n pi of negative 1 to the n minus 1. So in writing the f of x, our c naught was negative 1. plus we have I over pi times the summation of k equal to negative infinity going to infinity, where k cannot equal a 0, and you do need to mention that. So we have a negative 1 to the k power minus 1 divided by k, and we have to write e to the I k pi x divided by 3. So this would be our answer. And if you really wanted to get rid of the k cannot equal to 0, you can substitute in 2k minus 1, and I'll write that here. Or negative 1 minus 2I over pi summation of k going from negative infinity to infinity of e to the I 2k minus 1 pi x divided by 3, and that whole thing divided by 2k minus 1. So that's if you sub in 2k minus 1 for k. Any questions on this? And that would be it. Thanks for coming, guys.